In this video, we will discuss gas laws and intermolecular forces. Vapor pressure. The higher the vapor pressure, the more molecules are in the gas phase. The higher the vapor pressure, the easier it is to escape the liquid phase. Weak intermolecular forces, and it will boil at a low temperature. The lower the vapor pressure, the harder it is to escape the liquid phase. The stronger the intermolecular forces are, and it will boil at a higher temperature. As the pressure increases, the boiling points also increase. As temperature increases, vapor pressure increases. If air pressure decreases, less pressure keeps liquid in its liquid state, so the boiling point decreases. Water boils when the vapor pressure equals atmospheric pressure. Gas laws. Standard temperature is 273 K or 0 degrees Celsius. Standard pressure is 1 atmosphere or 101.3 kilopascals. All gases are composed of individual particles that are in continuous random motion in all directions, moving in straight lines. There is a transfer of energy between colliding particles. The total energy remains constant. Total kinetic energy remains the same as long as temperature and volume don't change. The volume of individual gas particles is insignificant compared to the volume of space in which they move. No force of attraction exists between gas particles. These are all aspects of an ideal gas. Hydrogen and helium act most like an ideal gas. Low temperature and high pressure bring the molecules closer together. Charles' law. As temperature increases, volume increases. As temperature decreases, volume decreases. Faster moving molecules push out the walls of the container. Here's a graph representing Charles' law and also the formula. V1 over T1 equals V2 over T2. Boyle's law. As pressure increases, volume decreases, and as pressure decreases, volume increases. Pushing harder forces molecules closer together. Here's the graph and the formula. P1 times V1 equals P2 times V2. Gay-Lussac's law. As temperature increases, pressure increases. Faster moving molecules collide with the container. P1 over T1 equals P2 over T2. The combined gas law can be used to calculate a gas's change in pressure, volume, or temperature. Avogadro's law. Different gases with different volumes but the same temperature and pressure will have the same number of molecules or moles. Molecular substance. A molecular substance is when two or more atoms are bonded together with covalent bonds. Molecules are primarily formed from the non-metal elements. Molecular substances are soft, poor conductors of heat and electricity, and have low melting and boiling points. Intermolecular forces are forces of attraction or repulsion which act between neighboring particles, atoms, molecules, or ions. They are weak compared to the intramolecular forces, the forces that keep a molecule together. As bonds become more polarized, the charges on the atom becomes greater, which leads to stronger intermolecular attractions, which leads to higher boiling points and decreased volatility, or ease of evaporation. The strongest to weakest intermolecular forces are ionic forces, then hydrogen bonding, then dipole-dipole interactions, then molecule-ion attraction, and finally dispersion forces. Ionic forces is just the force between ions and ionic compounds. Hydrogen bonding is an intermolecular force that connects one water molecule with another water molecule. It is responsible for the high boiling and freezing point of pure water and the formation of ice crystals. For hydrogen bonding, hydrogen needs to bond with a fluorine, oxygen, or nitrogen atom. Dipole-dipole forces. The molecule has two poles. One pole has a partial positive charge and the other has a partial negative charge. The molecules will arrange themselves so that the opposite poles attract. Molecule-ion attraction. The attraction between an ionic compound, example, salt dissolving in water, opposites attract. Dispersion forces. They are present in all molecules. It is weak forces between nonpolar molecules that are responsible for solid, liquid, and gas phases and increases with molecular size. As you go down group 17 and 18, dispersion forces increase and the boiling point increases. This is a review sheet that's linked in the description below, and we're going to go ahead and start. What is the normal boiling point of ethanoic acid? In order to determine the boiling point, we need to look at table H and see where the curve of ethanoic acid crosses the dotted line, because that's the line of the normal boiling point. Ethanoic acid crosses this line at some point between 115 degrees Celsius and 120 degrees Celsius, which means that the answer to this question can only be A. The strongest intermolecular forces of attraction exist in a liquid whose heat of vaporization is. The stronger the intermolecular forces, the higher the heat of vaporization should be, which makes the answer D. As temperature increases, vapor pressure increases as well, and this is something that's mentioned in the slides. Which of the liquids on table H has the least volatility? The liquid with the least volatility will have the highest boiling point, and that liquid with the highest boiling point is ethanoic acid because it crosses the normal boiling point line at the farthest value from 0. Which of the liquids on table H has the least intermolecular attraction? If a liquid has a weak intermolecular attraction, it means it has a very low boiling point. So we need to see which liquid has the lowest boiling point. That liquid is going to cross the normal boiling point line at the closest value to 0 of the other liquids also on table H, and that's propanone. The relatively high boiling point of water is due to hydrogen bonds because it acts between water molecules. Under which conditions of temperature and pressure does a real gas behave most like an ideal gas? Under conditions of low temperature and high pressure. This is just a basic thing that you have to know. Which statement describes the particles of an ideal gas? We can eliminate A because in an ideal gas, the particles move in random straight lines. We can also eliminate B because in an ideal gas, energy is transferred. And we can eliminate C because in an ideal gas, there are no forces of attraction between the particles. This makes the answer D. At the same temperature and pressure, 1 liter of COG and 1 liter of CO2G have. This is related to Avogadro's law. If they have the same temperature, the same pressure, and the same volume, then that means they're going to have the same number of molecules. This makes the answer C. At STP, 44.8 liters of carbon dioxide contains the same number of molecules as, so you have to remember that 22.4 liters equals 1 mole, so 44.8 liters equals 2 moles, and the only option with 2 moles is B. The table below lists 4 gases and their molecular mass. Which gas diffuses at the slowest rate at STP? The gas that diffuses at the slowest rate is the one that's going to be the heaviest because of its size, so the answer is D. A gas occupies a volume of 444 milliliters at 273 K and 79 kilopascals. What is the final Kelvin temperature when the volume of the gas is changed to 1,880 milliliters and the pressure is changed to 38.7 kilopascals? You can set this up using the combined gas law. So it's going to be 79 kilopascals times 444 milliliters over 273 K equals 38.7 kilopascals times 1,880 milliliters over the second temperature, which is what we're trying to figure out right now. If you do the math, you'll discover that T2 equals C. At 25 degrees Celsius, gas in a rigid cylinder with a movable piston has a volume of 145 milliliters and a pressure of 125 kilopascals. Then the gas is compressed to a volume of 80 milliliters. What is the new pressure of the gas if the temperature is held at 25 degrees Celsius? You can still use the combined gas law, but you don't need to include temperature because it's going to be held constant. So when you set up the problem, it'll be 145 milliliters times 125 kilopascals equals 80 milliliters times P2. And then when you do the math and you do 125 times 145 divided by 80, you'll get 226.56, and you could round this up to 230 kilopascals D. According to the kinetic molecular theory, which statement describes the particles in a sample of an ideal gas? We can eliminate A because in an ideal gas there are no forces of attraction, but the answer will be B because in an ideal gas, the gas particles move in random straight lines. Which sample of water has the greatest vapor pressure? The answer is D because it has the highest temperature, 35 degrees Celsius. The boiling point of a pure substance is defined as the temperature at which B, the vapor pressure equals the external pressure, and this is just a definition that you have to remember.